What's up everyone, welcome back, Patrick here, and in this next video what we got to do, we got to simplify all of these expressions here. So starting with number 1, we got xy to the power of -3 times x squared y to the 3 all to the power of 4. So first thing I'm going to do here, first thing I usually do in general, I look for negative exponents, try to change them to positive ones. So notice this -3 here, we have this expression to the power of -3, so we can rewrite all of this. This we would leave up top, but then this we can bring down. And that would change to a positive 3. Right? If you remember, a to the negative x is equal to 1 over a to the x. And in this case, this a is this whole expression xy, and then this negative x is this -3. So I just applied that right there. Then from here, what we can do, notice that these are multiplying, both of these expressions. There's an exponent on the outside, so it's like ab to the power of x, which is equal to a to the x, b to the x. So this x squared, which is like this a would go to the power of 4. Then we got the y to the 3. That would go to the power of 4. Then we got like x to the 1, y to the 1. So we'd have x to the 1 goes to the power of 3, and then y to the 1 goes to the power of 3. Like that. Then from here we can multiply these using this rule. We can multiply the exponents, so we'd have x to the 8, y to the 12, all over x to the 3, y to the 3. And then we have the same basis here, so we can subtract the exponents. X to the 8 divided by x to the 3 would be 8 minus 3, which would be x to the 5. 12 minus 3 would give us 9. And so that there ends up being the final answer to number 1. Moving on to number 2, we got x to the 4 over y to the 3 to the power of -3. So first thing I like to do with this kind of question is first try to simplify everything in the brackets, but notice in the bracket x to the 4 over y to the 3, different bases, can't simplify that any further. So then I move to the outer exponent. Notice that that exponent is negative, so what we can do is we can flip the fraction and then change it to a positive exponent, right? Just in general, if you got this, this is equal to that. And then what you could do is the numerator goes to the power of x, and then the denominator goes to that outside exponent. So if we apply that here, we'd have y to the 3 to the power of 3, then we'd have x to the 4 to the power of 3 as well, and then we'd have y to the 9, x to the 12, and that actually doesn't simplify any further. So this here would end up being the final answer for number 2. And then number 3, so notice in this case there's a -2 on the outside, but there's a lot more going on inside the bracket versus this one. So we got x to the y to the -2 and then all over y to the 3. So again, I'm going to work with this inside bracket first, simplify as much as possible, then move to that outside exponent. So this xy to the -2 I can bring down, so we'd be left with 1 up top. Then we have x to the y to the +2, y to the 3, and that's going to be to the -2. Now, you don't necessarily have to go about it this way. You can actually just, if you wanted to, take this outside exponent and then take the numerator to that, denominator to that, and then simplify. Different ways to go about it. Just make sure whichever way you do it, you're getting the same answer at the end. So here, this would end up being 1 over, this would be like x to the 1 squared, y to the 1 squared. If we take that 2 distributed to both of these, since they are multiplying, then we have the y to the 3, and then we still have that -2. So this would end up being 1 over x squared. We multiply these exponents, y squared, y to the 3, all to the -2. And this would end up being, notice that the y to the 2, y to the 3, those are the same base, so we could add those exponents since they're multiplying. X to the 2, y to the 5, like that. So notice we can't simplify this bracket any further, so all of this here simplifies to that. And so continuing this here, what we can do is move to the outside exponent. Since it's a negative, I'm going to flip this fraction. So we'd end up with x to the 2, y to the 5 over 1, all to the power of positive 2. And then this 1 we could ignore, right? Because anything over 1 is just itself. So it ends up being x to the 2, y to the 5 to the power 2. So we'd have x to the 2 to the 2, y to the 5 to the 2. And then this would end up being x to the 4, y to the 10. So that ends up being the final answer for number 3.